call is now being recorded.
Now you can observe that in this figure. So voltage developed across the two halls. So this one is the VS1 and this one is the VS2. So two voltage center at the secondary of the center tap. So what are the current, what are the voltage developed? So that is divided into two halves. Now see the working for the center tap full wave rectifier. So in the positive half cycle of the input voltage, in the positive half cycle of the input voltage, you can observe that this point A is positive with respect to B. A is positive and B is negative. So from this you will get the positive half cycle and here you will get the negative part of this half cycle. For the diode, so anode is connected to the positive. When anode is connected to the positive terminal, so diode D1 acts as a closed switch. This diode D1 turns on. When the diode D1 turns on, so you will get the output voltage V0 across this load resistance RL. And the direction of load current, you can observe that. So this is the direction of load current from the point A again to the center tap terminal. So here you will get the load current IL and the output voltage V0. Now in the negative half cycle of the input voltage, now this A terminal which becomes negative and B terminal which becomes positive. So this terminal A, as it is negative and the negative voltage is applied to the diode, then the diode turns off. When the diode turns off, it acts as an open circuit. And as now this voltage becomes positive in the second hall. So here at the position B, you will get the positive input voltage. Because of the positive input voltage, diode D2 turns on, and because of the negative input voltage at point A, diode D1 turns off. Diode D1 acts as an open switch and diode D2 acts as a closed switch. When diode D2 acts as a closed switch, here you will get the load current IL. Same direction as like in the when diode D1 is conducting, whatever the direction of load current you will get, same direction of load current you will get at the output. Now because of that, at the output you will get, now see the direction of voltage. So this is the input voltage. For the input voltage, diode D1 is conducting. Now see the load, this is the load current and the load voltage. So load current and the load voltage. For the positive half cycle, so here you can observe for the positive half cycle, here you will get the positive voltage as well as for the negative input voltage, also you will get the positive voltage at the output because the direction of current is same both for this diode D1 and diode D2 when they are conducting. So this is the circuit diagram. For the center tap full wave rectifier. Now we will see the third circuit, that is a bridge rectifier. Now to design a bridge rectifier, so what is the requirement? A step down transformer is necessary and 4 rectifier diodes and one load resistance RL is required. Now you have to arrange this diode in a bridge like a structure. You can observe that in the circuit diagram. Here a bridge like structure is there. So you can adjust this bridge type of structure. Now here you can see diode D1 and D2 having same direction, and diode D3 and D4 having same direction. So diode terminal of anode of diode D1 and cathode of D4 are connected. Diode D1 cathode and diode D3 cathode are connected. Diode D2's cathode and diode D3's anode are connected. So this is the bridge type of structure. Now see the working of the full wave bridge rectifier. We have seen that for the half wave rectifier, so transformer is used only for the positive half cycle. But here you can see that the transformer used in the both half cycle. So the transformer utilization is best possible when we are using a bridge rectifier. Also, this bridge rectifier doesn't require a center tap transformer. Cost of the center tap transformer is high as compared to the two terminal transformer. Now see the working for this bridge rectifier. Now for the bridge rectifier, consider for the positive half cycle of the input voltage. For the positive half cycle of the input voltage, you can observe that here diode A is positive, terminal A is positive with the terminal B. As terminal A is positive, so where that voltage goes? So that voltage goes to the diode D1 through load resistor RL and through the diode D2. Now see the direction of current flowing through the device. Again, I will explain. From point A to diode D1, from diode D1 through load resistance RL, from RL to diode D2, and again from diode D2 to the terminal B. So here you will get a closed loop of direction of current. So for this bridge rectifier, as A is positive with respect to B, at the output you will get the positive voltage. So here you can observe that for the half cycle, for this position, diode D1 and diode D2 turns on. For the first positive half cycle, diode D1 and diode D2 turns on. And at the output, you will get the whatever the input voltage, the same voltage at the output you will get. Direction of current is same. So this is the current. So this current, that is the maximum current IM. So you can calculate the current through diode D1 and D2. So current IM equal to maximum voltage VM divided by load resistance RL. So for this positive half cycle, diode D1 and D2 turns on. Right? Now see for the negative half cycle of the input voltage, what happens? So for the negative half cycle of the input voltage, as terminal A now becomes negative and terminal B is positive. So as terminal A is negative, so this negative voltage is connected to the diode D1. So the diode D1 get reverse bias. As diode D1 is reverse bias, so there will be no current flowing to the load resistance RL. And because of that, diode D2 also turns off. Diode D1 and D2, these are turns off. And as we are applying a negative voltage to this, so because of that diode D4 turns on. So as diode D4 turns on, as well as diode D3 turns on, as terminal B is positive and A is negative. So as B is positive, so diode D3 is positive. So this positive voltage now flowing to the load resistance RL. See the direction of current through diode D4 and again to the device A. Here at the point A, you will get the current direction from B, D3, RL, D4 and again to the point A. But you can observe that same direction of current you will get at the output. Now see in the waveform. See, for the negative half cycle of the input voltage, so this is the negative input voltage. Can you observe the waveform? Now see, for the negative half cycle of the input voltage, diode D3 and D4 turns on. When diode D3 and D4 turns on, you can observe that the same direction of voltage and the current you will get at the output as like diode D1 and the D2. So for bridge rectifier, so entire secondary of the transformer is utilized continuously. So the transformer utilization factor for the bridge rectifier is more than the half wave rectifier and the center tap full wave rectifier. Now see the comparison of half wave and full wave rectifier. So for half wave rectifier, number of diodes required are 1, and for full wave rectifier, for center tap, 2 diodes are required. And to design a bridge rectifier, 4 diodes are required. For half wave rectifier, the secondary voltage is, you will get the maximum voltage, that is Vm. For full wave bridge rectifier, for center tap, you will get 2 types of Vm, and for bridge type, you will get the Vm voltage at the output. For half wave rectifier, it will conduct only for 1 half cycle, and for full wave bridge rectifier, you will get positive voltage for both the half cycles, positive as well as for the negative. So now see the DC output voltage. DC output voltage is Vm divided by pi for the half wave rectifier, and for full wave rectifier it is 2 Vm divided by pi. Now if we calculate the efficiency, then for half wave rectifier, the rectification efficiency is 40.6%. For full wave bridge rectifier, it is 81.2, both for the center tap as well as for the bridge rectifier. And you can observe that the center tap transformer utilization factor, if we calculate, so you will get the maximum utilization factor for the bridge rectifier. And peak inverse voltage is Vm in both half wave rectifier as well as bridge rectifier. But in center tap full wave rectifier, the peak inverse voltage you will get two types of Vm.